In a small office at Kansas State University, a computer scientist stares at a chart on his monitor. He has just fed the deepest images JWST has ever taken. 263 galaxies, light older than every memory you have, into a script that asks one tiny question. Which way is each one spinning? The bar on the right keeps growing. The bar on the left doesn't. By the time the run finishes, 2/3 of the universe is rotating the same direction. He picks up the phone, because if this number is real, the next sentence out of his mouth is going to sound completely insane. By the end of this video, you will understand why a histogram in Kansas might be the first observational fingerprint of a parent black hole, and what it means for where exactly you are right now. Step back 4 years, Christmas Day, 2021. A rocket lifts off from French Guiana carrying the most expensive telescope humans have ever built. $10 billion. 3 decades of arguments. 344 single points of failure. Any one of them, and it's a $10 billion trash can floating in the dark. None of them fail. The sun shield unfurls, the mirrors lock. JWST parks itself 1,000,000 miles past the moon, where the cold is deeper than anywhere else in our solar system. And it opens its golden eye. Within 18 months, it has handed cosmologists a problem. The early universe is too bright. Galaxies that should be infant smudges are mature pinwheels. The Hubble tension keeps growing. Dark energy in 2024 looks like it might be weakening. Every measurement is sharper than ever, and the sharper they get, the less the standard story holds together. Scientists call this an era of precision cosmology. A more honest word might be crisis. And into this crisis, in February 2025, walks a man who is not a cosmologist. His name is Lior Shamir. He is not at Princeton. He is not at Caltech. He teaches computer science in Kansas. His specialty is machine vision, the kind of code that helps doctors find tumors in CT scans. For 15 years, on the side, he has been pointing the same kind of code at galaxy images, looking for something almost nobody believes is there. A preferred direction in the universe, a cosmic axis. He has been politely ignored for 15 years. Then JWST releases the JADES survey, the deepest, sharpest infrared field ever taken. 800 hours of telescope time, 2 patches of sky, 263 resolvable spirals at the edge of seeing. He runs his classifier. The histogram comes back lopsided. He runs it again, with the images flipped left to right. The asymmetry inverts exactly, the way it should if the signal is real, and not a quirk of his code. He says it himself in a quote that goes everywhere. The difference is so obvious that any person looking at the images can see it. But here's the part that makes everything stranger. Because if this asymmetry is real, only one published theory in modern physics actually predicts it. And that theory has been waiting patiently on a shelf for 15 years. In a small office in Connecticut at the University of New Haven, a Polish theoretical physicist named Nikodem Popławski has spent a decade and a half doing math nobody asked him to do. He works on something called Einstein-Cartan torsion, an obscure cousin of general relativity that adds one extra ingredient to spacetime, a twist, a handedness, a spin that fabric itself can carry. In 2010, he published a paper. The math said something gentle and outrageous. If you fall into a large rotating black hole, and every astrophysical black hole rotates, you do not get crushed into a singularity. The torsion in spacetime turns repulsive at extreme density. Matter falling in bounces, and the bounce inflates a new region of spacetime on the other side. To anyone living inside that region, it looks exactly like an expanding cosmos. Stars, Galaxies. 13.8 billion years of history. A universe. Now imagine that universe inherits one detail from its parent. The parent black hole was spinning, so everything born inside it tilts just a little toward that spin axis. Galaxies forming a billion years later carry a faint memory of which way their cradle was turning. Most rotate the same direction. Some, perturbed by gravity, rotate against the grain. The signature on the sky would be exactly what JWST seems to see. 158 clockwise, 105 counterclockwise, a 2-to-3 ratio that should not exist in a universe with no preferred direction. Popławski's words, in a phone call to a journalist in 2025, were almost too calm. The simplest explanation, he said, is that our universe was born inside a rotating black hole. For 15 years, his paper had been a footnote. JWST just made it a possibility. Sit with that for a moment. Every star you have ever wished on, every photon that reached your eye from Andromeda, every mountain on Mars, every fossil in every cliff, every person who has ever lived, every kingdom that has ever risen, every song anyone has ever sung, all of it happening inside the interior of something, a collapse in some other place that we are living inside of. The Big Bang would not be a beginning. It would be a doorway, a star, somewhere we cannot see, ended. And we are what happened next. This is not a small change to the cosmic story. Copernicus moved Earth from the center. Hubble moved our galaxy from the center. The multiverse moved our universe from being the only one. And now the question is whether our universe is even freestanding, or whether it is nested inside something, the way a dream sits inside a sleeping mind, the way a room sits inside a building you cannot exit. If Popławski is right, the cosmos is not a thing. It is a thing inside a thing, and every black hole humans have ever drawn an arrow at, Sagittarius, a star at the heart of our own galaxy, the supermassive monster in M87 that humanity photographed in 2019. Every one of them might be a doorway to a baby universe we will never visit, with its own Earths, its own oceans, its own children, looking up. But before you redecorate your worldview, hear the prosecution, because cosmology is full of extraordinary results that quietly evaporated, and serious people are not convinced. 263 galaxies is a tiny sample. The observable universe holds something like 2 trillion. DESI, a separate survey, has measured around 100 million galaxies and found no rotation bias. Euclid, the European space mission, is now mapping a third of the sky. Early data partially, also no asymmetry. The Shamir result might be a fluke of which little patch JWST happened to point at, or it might be a quirk of the classifier. Galaxies at the edge of resolution are blurry, and blurry shapes can fool even careful algorithms. There is a quieter critique, too. Earth is moving. Our galaxy is hurtling through space at hundreds of kilometers per second. Light from galaxies whose spin opposes our motion arrives slightly bluer, slightly brighter, and a slightly brighter galaxy is slightly easier for JWST to detect. Maybe what looks like a real cosmic rotation is just a Doppler shadow cast by our own velocity. The numbers don't quite add up. The Doppler bias should be tiny, far too small to make a 50% skew. But at the edge of resolution, should be tiny has fooled physicists before. And then there's the philosophical strike. Sean Carroll, in a blog post from 2010 that keeps getting reshared, made a simple point. To call something a black hole, you need an outside it can be observed from. The universe has no outside. Calling the cosmos a black hole, he wrote, is poetry, not physics. He's not necessarily right, but he's not necessarily wrong either. And in 2026, nobody, not Shamir, not Popławski, not Carroll, not the DESI team, actually knows. Step back from the courtroom and look at the whole sky. Modern cosmology in 2026 looks a lot like physics in 1900. Back then, classical mechanics worked beautifully, except for a handful of small, embarrassing anomalies: the blackbody spectrum, the photoelectric effect, the orbit of Mercury. Each one alone seemed boring. Together, they were the seeds of relativity and quantum mechanics. The walls were already cracking. Nobody could see it yet. Today, the standard cosmological model, lambda CDM, works beautifully too. Except, the Hubble constant gives you two different numbers depending on how you measure it. Dark energy, the largest mystery in the sky, looks like it might be evolving instead of constant. JWST keeps finding mature galaxies far too early. The S8 tension, the cosmic dipole anomaly. And now, maybe the universe rotates. Each one alone is probably nothing. Stacked together, they look like the polite, statistical, peer-reviewed version of a building creaking before a storm. Whether or not Shamir's specific paper survives the next round of telescopes, the field itself is whispering that something deeper is wrong. And whatever the answer turns out to be, the universe of 2030 is going to look stranger than the one we grew up in. Here is what I keep coming back to. Every Copernican revolution has felt, at the start, like a demotion. Earth is not the center. The sun is not the center. Our galaxy is one of 2 trillion. Our universe might be one of infinitely many. And now, perhaps, our universe is not even a freestanding thing. It might be a single chamber inside, something vaster. We cannot see, but notice what actually happens when we accept each of those moves. We do not feel smaller. We feel more curious. The sky did not get less interesting when we learned Earth orbits the sun. It got more interesting, whatever the next move is. Universe inside a black hole. Universe inside a multiverse. Universe inside something nobody has named yet. It will not make you smaller. It will make the next moment you look up at the stars feel a little stranger and a little kinder, because you will know that the dark you are looking into is not empty. It is full of questions that the most careful telescope humans ever built has only just begun to ask. So, the next time you look up, remember the histogram in Kansas, the torsion equations in Connecticut, the spinning galaxies in JADES, and the quiet JWST is whispering that reality, at the largest scale, might be nested inside something we will never see. But there is another scale where reality is just as strange, the one inside your skull, the one doing the looking. In June 2018, in a quiet hotel ballroom in Buenos Aires, 2 of the world's leading consciousness theorists shook hands and made a bet. Christoph Koch defending integrated information theory, Stanislav Dehaene defending the global neuronal workspace. 2 completely different stories about how 3 pounds of wet tissue conjure the experience of being you. They committed to a 7-year adversarial collaboration. Same experiments, same data. May the better theory win. The verdict came in 2025. Both theories lost. Ship title suggestions, 5 options. JWST. Just found evidence. Our universe is inside a black hole. 2148 versus 105. The number that might break cosmology 3. Are you already inside a black hole? JWST 2025 says maybe. 4. The telescope that found a doorway in the sky. 5. Why 2/3 of the universe spins the same way.